Okay, so let's start. We'll continue to discuss use case detailed specification. So last time we mainly focused on high-level design of use cases, the actors and use cases, identify the main use cases. Now we're going to describe the internal details of each one of the use cases, what's in the obels. So precondition is a statement about the state that the system must be in order for the use case to be performed. So precondition states what should be true, not how it's made true. So the use case is always started by an actor, initiated by an actor, but under the condition that the preconditions are true. So, for example, the student registration use case may have a precondition that the student doesn't have any outstanding bills on his account. And flow of events is a sequence of actions needed to accomplish a use case. It describes what the system and the actor should do to perform the use case. Ignore use case interactions. That is, we always have independent use cases. They should never interact with each other. Each use case is a complete flow of events. So a basic flow is the normal behavior from start to end. That is so-called silent day scenario. That is, everything goes smoothly, nothing goes wrong. What happens usually is always required. The alternative flows are optional, variant, exceptional, or error behavior. That is, when something unexpected happens, it's more like an exception handler. So you start with the basic flow. Then add alternative flows as needed to specify everything that the user might do. So the narrative should be event response oriented. So the actor does something, the system does something in response, and actor does something again, system does something. So it should have these styles of specification. So flow of events is essentially a sequence of short steps that are numbered, declarative, and time ordered. That is, you specify 1, 2, 3, 4, and order them in terms of the time sequence. You do something first, something next, and something next. So you may have, besides the linear flow of events, you may have branching condition, like if a Boolean expression is true, you do a bunch of statements, and if it's false, you do something else. So, or you can have repetitions, like you have 4 iterative expression, and while this condition if you iterate, for example, iterate a counter over from 1 to 100 to do something, or you can have a while. So while the Boolean expression is true, you do a bunch of steps, declarative statements. So these are if, for, and while are just like in programming languages, but they should be used sparingly. That is, the use case detailed specification should be mainly line-by-line descriptions. Only use these if for a while, when necessary, don't use them too much. So use case specification should be kept as simple as possible. You're not writing a program. You're just specifying the steps of each use case. So a subflow is a segment of behavior within a use case that has a clear purpose and is atomic. Essentially, the goal is to improve readability. That is, you can write a use case flow of events as a long list of steps, or you can pull out some parts of it as subflows, and so that you can have a high-level structure of the flow of events to be more clear. So these are like function calls. So subflows should be numbered as S1, S2, Sn, where S stands for subflow. There should be uniquely named within the use case with names that indicate their purpose. A subflow is referenced using perform, this keyword perform, subflow followed by a subflow name. Just like a function call, as I mentioned. So extension point is a named place in the flow of events where additional behavior can be inserted. That is, you can specify some points where you can specify when something condition becomes true, you do something in place of the normal behavior. So extension points may be private, where they're used only within the use case in which they appear, or public, where they can be used by other use cases. So when it's public, it is called an extent use case. So we'll discuss more details on this. So extension points may be at a single location, or a set of discrete locations, or a region. That is a set of locations between 2 points in the flow of events. So that is, when something interesting happens within the whole region, you can perform something alternative. So it's used for defining alternative flows. We'll see some examples next. So alternative flow describes the optional variant or error behavior. These are exception handlers. Allows functionality to be added incrementally to the basic flow. So you start with the sunny-day scenario and finish the basic flow first, and then you think about what can go wrong. So different alternative flows include a specific alternative flow starting at a specific named point in another flow of events. So you specify a particular point and say, at this point, if some condition becomes true, you perform the alternative flow. Or it can start at any point within a use case. That is, at any point when something becomes true, something happens, you perform the general alternative flow. Or a bounded alternative flow can occur between 2 extension points. So these are related to the extension points. So if you have a single location, extension point is used for the a specific alternative flow, while a region extension point or a set of discrete locations as extension points are used for the bounded alternative flow. And also, a general alternative flow can happen anywhere in the use case. So alternative alternative flows should be numbered as A1, A2, AN, where A stands for alternative. They should be uniquely named within the use case to indicate their purpose, similar to the subflows. So the alternative flow, the first line has the form at extension point when some event occurs, or at extension point if some condition is true. So it can be triggered by some event happening or by some condition turning true. So extension point is the point you specify in your basic flow as tags, right? And then in the alternative flow, you specify where you perform the alternative flow at these specified locations. So the last line of an alternative flow event and other exit points within it must state explicitly where the actor resumes the flow of events. That is, say you're handling an exception, right? Something extraordinary happens, you invoke exception handler, but where does the flow of control return to? So for optional behavior, this will be the original extension point where the alternative flow was triggered. So this is like a function call where you call a function something, you finish the function, you return to where you called the function. For truly alternative behavior, this could be another extension point elsewhere in the flow of events. That is, you may jump to somewhere else instead of the place where you left the basic flow. So this is more like exception handler where you can usually jump to another location in the program. So for exceptional behavior, usually the use case ends, which should be explicitly stated in the alternative flow of events. So exceptional behavior means that something really wrong has happened. This should not happen. So if that happens, then the use case should end. Three different places you can resume. So for exceptional behavior, you just end. You don't resume at all. For optional behavior, you resume where you started. And for truly alternative behavior, you resume at another extension point. So post-condition, as opposed to a precondition, it is a statement about the state or condition the system is in at the conclusion of a use case. So it may be omitted, it's optional, if the system state is not important to how the use case ends. It is really seldomly required. So when it's needed when the completion of the use case leaves the system in a particular state that may need to be a precondition for another use case. So then you specify the post-condition explicitly. So for example, depositing money into a bank account may leave your account with more money, which may be a precondition for another withdrawal money use case. So in that case, you may need to specify the post-condition as to how much money is in the account. So the possible outcomes of the use case are not obvious, so that it will be difficult for developers, testers, or users to understand the result of performing the use case. So then you specify the post condition explicitly to specify the exact outcome of the use case. What happens at the end? So post conditions help ensure that the reader understands what the result of executing the use case has been. So the post conditions always hold when the use case finishes, no matter how it finishes. So if the system can be in different states, depending on the path taken through the use case, then you should enumerate these states. Oftentimes, the use case can take multiple paths through it. For example, if you have an if in the flow of events, then perhaps different branches of if will result in different post conditions after the use case finishes. So how much is enough? So how much detail is enough? A use case is a technique for mitigating risk. There are many risks in software development, including technical risks, all the other risks. So this particular risk is that someone might misunderstand what the system is required to do to produce value for its users. So it's used for reduce misunderstanding and help people, including users and developers, understand the system better. So it must contain enough detail so that all stakeholders are satisfied that the system is defined in sufficient detail to allow the right system to be built. Stakeholders, including the client and the developers and the users. So everyone should understand it to a level where at the end you know that the system is the right system to be built. Therefore, the basic flow should unambiguously describe the required behavior. So you should keep asking, what does this mean, until all the ambiguities have been resolved. So the key is to be precise, and because it forms as part of the requirements document and forms as the basis for acceptance testing. That is, you design your acceptance tests based on the use case flow of events, essentially like a step-by-step translation from a use case flow events to acceptance tests. Therefore, it should be very precise to avoid any disputes in the future. So, use case model detail, you can have generalization. Since actors and use cases are classifiers, that is, they're classes, even though they look funny. They're just special classes. So anything that applies to classes also applies to actors and use cases. So, for example, they can be generalized. We saw this before already. So you may have an employee as an actor, and you may have a sales clerk and manager as subclasses of the base class employee. We saw before a customer and a member has a generalization relationship, and a clerk and a manager. So this is an actor inheritance. You can also have use case inheritance. So for example, you may have a use case validate user, which may be performed in two different ways. One is check password for validating the user, or you can scan retina for validation. So So both perform the same functionality of validating the user, but with different techniques. So the use of generalization represents a design decision. That is, you can always not use generalization, and but having them can help you reduce the clutter in your diagram. So, for example, any use case that the employee can perform can also be performed by their subclasses, sales clerk and manager, so that you can draw fewer lines in your diagram. So it includes use case. Let me see. So many use cases may share pieces of the same functionality. So we can extract this functionality, put it into a separate use case, and relate it to all the other use cases that need it by an include relationship. So, for example, both maintain student information is a use case. Maintain professor information is another use case. They may both need to perform the validate person information as part of its flow of events. So you may pull it out into a separate so-called include use case, which is included by the two main use cases. Kind of like a function call, and this validate person information use case is usually not invoked directly by an actor, but it is invoked as part of the maintain student information and maintain professor information use cases. So the include use case is very much like a subflow in the use case flow of events, except it can be shared among multiple use cases, while a subflow is a purely structural mechanism within a single use case. So the include use case represents a design decision. You can always duplicate this validate person information inside each one of the base use cases. It wouldn't be wrong, but having an include use case will help you reduce the size of your use case specification. Just like having a function call function defined can help you reduce the size of your main program. So we'll look at one example use case. So this is for the ASU example. So here's a particular subflow S1. S stands for subflow. Add new student. So you have 1, 2, 3, 4, 5, 6. 1 is the system displays a blank student information form, and register fills in the student information. Register confirms the entered information, and then at step 4 you say include use case validate person information. So this validate person information is the name of the included use case, which has its own flow. So the brief description says that this use case is included by other use cases to check the correctness of the entered common information. about people in the university includes first, user ID is validated to be unique among user IDs in the system, etc. So, and then after you invoke the include use case, you continue on with the number 5, check the correctness of the student-specific information, and number 6. So notice that the include use case sets valid person information. Therefore, you may have additional information specific to students that you need to check within the base use case of maintain student information, and also specific information related to professors that they need to check in the maintain professor information. So the use case valid person information only checks for all information generic to a person, like a person's Hong Kong ID is correct, had the birth of date, etc. So sometimes a use case description can be inserted into and extend the existing use case. So you may have a base use case, select courses to teach, and you may have an invalid semester use case that is plugged into, that extends the select courses to teach use case. It models conditional additions to use cases, sequence of actions. That is, when some condition happens, that is, invalid semester happens, then you invoke the extend use case. Used to show optional behavior or behavior that's only executed under certain exceptional conditions, or customization of the requirements for specific client needs. So the base use case may be rather generic, and then you may specify multiple extend use cases. So the use of extend use case represents a design decision. So you can always not use it and put everything in the base use case. So extend use case is similar to the alternative flow, except the difference is that extend use case may be shared among multiple use cases, while alternative flow is only used within a single use case. So time for some examples. So here's the use case. Here's the detailed specification of the flow of events for the professors select courses to teach. I think it's a little hard to read. So here's the first. You have a brief description. This use case describes how a professor selects courses to teach for a semester that has not started. And then you have the use case diagram. A professor as an actor, a select courses to teach as a use case. And you have a precondition. The user is logged on as a professor actor, so login is the precondition. Without logging in, you can't do anything. The basic flow has these steps. So the use case begins when the professor actor selects the options, select courses to teach. System displays the interface to selecting courses to teach. And professor indicates the semester and year in which he would like to teach courses. So this is a extension point. Enter semester. So these extension points can be used to specify alternative flows in the future. So, and another extension point, select activity. These are like tags that you place into the flow of events that you can refer to later. So while the professor has an activity to perform, you see a while here. If the create activity is selected, you do these steps. So begin creating schedule. That's another extension point where the system retrieves and displays the available course information for the given semester if the date for changes has not passed. And you see another extension point, deadline passed. That is, if this point is reached and the deadline has passed, then you may perform some alternative flow. And the second step is that the professor selects the courses that he would like to teach. And third step says professor confirms the selection. System creates the professor's teaching schedule. System notifies the professor that the teaching schedule has been created. So as you can see, this whole flow from 4.1.1 to 4.1.5 is the basic flow. You may later add some alternative flows to specify what happens when some exception happens. So you may specify. So we just saw the create activity, and then you may also select the review activity. That is, review the professor's teaching schedule, or modify activity where you system retrieves the professor's teaching schedule, and the professor adds course sections to and or deletes course sections, and professor confirms the changes. System updates the professor's teaching schedule. System notifies the professor that the modifications have been made. And finally, the use case ends. So essentially, this use case has three main branches representing the three ifs. If the create activity is selected, you do a bunch of stuff related to creating a schedule. If the review activity is selected, you do review the schedule, and if the modify activity is selected, you do modify the schedule. So alternative flows can be specified as A1. A stands for alternative. Invalid semester is the name of the alternative flow. So add select activity. If the entered semester or year is invalid, then you perform something, inform the professor that the semester or year is invalid, and resume the flow of events at enter semester. So select activity is this extension point we defined earlier. In the basic flow, we had a parentheses select activity. This is a tag, and the alternative flow says at this point, if something happens, then jump out of the basic flow and perform the alternative flow. And after you're done, go back to this point and continue with the basic flow. So that's the when the entered semester or year is invalid, you jump to A1 and perform these two steps, and then resume at the original place. But if the entered semester or year is valid, then you just ignore. You don't perform the alternative flow. Another alternative flow is when the schedule exists. That is, oh, that's better. Before at begin creating schedule, if the schedule already exists, then you inform the professor that a schedule already exists and resume the flow of events at a select activity. So that's another extension point, begin creating schedule, that we defined earlier. That's here. So at this point, if something happens, if the schedule already exists, you perform the alternative flow schedule exists. And A3 is no section selected. That is at one of these two extension points if the professor has not selected any sections of courses. So say Comp211, you may have section 2 or section 1, section 2. Which section do you want? If you didn't select any sections, then the system notifies the professor that this you must select a section and resume the flow event at a different location. So you have A4 alternative flow change date passed. So if the final date for changes has passed, then you reject the request and use case ends. So this is the truly exceptional flow where if this happens, then nothing else should be done. You should just finish. Or cancel activity is when at any point between begin creating schedule and confirm creating schedule, or between begin modifying schedule and confirm modifying schedule, you cancel the activity. So resumed at select activity. So this is the example of a region of extension points. That is, you specify a pair of extension points, begin creating schedule and confirm creating schedule. And at any point within the region between these 2 points, if the professor selects cancel, then you perform this alternative flow, A5. So another style of specification is when you use subflows to make the high-level flow more clear. So here, if the create activity is selected, you say perform subflow create schedule, where the subflow is defined as S1, begin creating schedule, and 1, 2, 3, 4, 5. So this is essentially, compare this to the previous style where you place the 1, 2, 3, 4, 5 directly into the basic flow. Well, in the subflow, in the second style, you are using subflows to pull it out into a separate location. And in the basic flow, you only specify, you only say perform subflow. And if the review activity is selected, you put this flow events here without using a subflow because it's only one step. It's not worth it to pull it into a subflow. And if the modify activity is selected, you perform subflow modify schedule and use case end. So this is more clear, right? You have a higher, more clear view of the high-level structure of the flow of the events compared to the previous style. And then you have the subflow definitions, which is essentially a copy of the detailed steps of each subflow. And alternative flows are the same. So I think this example is not in the slides. I will post it online later. So as I mentioned, extends use case, it's just like alternative flow, except it can be used among multiple, shared between different use cases. similar to the include use case. Include use case is just like a subflow, except include use case can be included by multiple base use cases, while a subflow can only be in a single use case. So use cases do not directly communicate with each other. That is, use cases are always independent from each other. They interact by changing the state of the system, but they do not directly talk to each other. Each one is always an independent sequence of actions. So each use case is intended to be independent of all other use cases. If it's dependent, then perhaps you should put them into a single use case. So be careful not to decompose the system behavior into use cases such as log in, select product, enter order information, enter payment information, confirm order. These are really detailed specifications of flow events. These are not individual use cases. So a use case is a cohesive end-to-end activity that is performed to accomplish a task for the user. While each one of these is not a independent activity. You always perform these in a group, not independently. Therefore, they should not be independent use cases. Is each of these things independently valuable? They're not. They're only valuable in a group. So would you ever do just one without the others? So that's the question you ask when you decide how to group these operations into use cases. So any questions on use cases?
So can we use the use case diagram to represent the flow, or we have to use some specification to represent the flow?
Yeah, the flow of events is always separate. So here's the use case specification. It includes a basic brief description. The use case diagram is just a part of the use case specification. And then you say preconditions, basic flow, that's flow of events. So the flow of events is always specified in conjunction with the use case diagram. Use case diagram is this high-level diagram, while the flow of events describes the details within this oval. Right?
Okay, so is there any standard pattern or style in the specification of the flow?
Well, there's not a real standard as to how you write the flow of events, but in this course we just use this style, essentially 1, 2, 3, 4, and when you have some steps, while if you say 4.1 and 4.1.1, 4.1.2, etc. And then for alternative flows, you say A1, A2. For subflows, you say S1, S2. So that's the convention we adopt. But there's no real official standard as to how they're written. So they're very informal.
So can I treat it as a kind of pseudocode or something like that?
It is pseudocode, except it's at the requirements level, not at the implementation level. So you're stating this flow of events from the perspective of the actor and the interaction between the actor and the system, not the internal implementation of the system. So I think in the previous slide I had a what's in the use case. So a use case specification includes use case name, brief description, actors shown in the use case diagram, precondition, flow events, post-condition, alternative flows, special non-functional requirements, which we'll discuss next. So the use case diagram is just a part of the use case specification. All the others may also be there. Of course, many of these are optional. So we're to go into non-functional requirements. So what are non-functional requirements? They are additional constraints placed on the use case or on the system. They essentially describe how well the system works. So the main functional requirements refer to what the system does, what the system can do. While non-functional requirements specifies constraints on how well the system does it. So including maintainability, reliability. Maintainability is when you need to add a new module to it or fix some defect, how hard it is. Reliability is when how often it crashes. Performance, including speed, throughput, response time, etc. Throughput is when how many users can you handle in a minute. Response time is when the user clicks a button, how long does it take to get it back a response. Interface, including user interface, interaction with the human user, learnability, usability. Is the system easy to use and easy to learn? Or interface with the external system, like file formats and timing. That is, if it's a real-time system, then timing could be a part of the interface. Hardware constraints like implementation platform, Windows or Unix or Linux, memory size, storage capacity. So if you're developing software for a handheld device, then perhaps you have very little resources in terms of memory and disk. But if you're developing software for a large server, then you have plenty of memory and storage. Implementation like standards, languages, error handling. So some organizations may standardize on, say, Java. Security, like system access, data access, physical access. That is the system locked up in the closet, or is the system kept at the company's site, or is it given to each user to take home? So that's physical access. Physical environment, abnormal conditions, and distributed operation. For example, if you're developing a system for military use, then you should place special requirements for the system to withstand extreme conditions. Documentation, what documentation is required and for whom. So management, including system backup, installation, maintenance, that's the job of the IT staff typically. So all these are captured as supplementary requirements on use cases or on the system as a whole. That is, you have the main functional requirements, then you add a supplementary section to it. So some non-functional requirements to be implemented as administration use cases, like login, startup, shutdown, backup. So login relates to the security requirement, while startup, shutdown, backup relates to the system management requirement. So we move on to user interface. So the UI is the packaging of the software and the most visible part of the system from the user's viewpoint. It establishes a dialogue between the system and the user, which needs to be clear and unambiguous. So all the user sees is the UI. He doesn't see anything beneath the UI. Therefore, UI specification determines what information passes between the actors and the system through the UI and what the UI will look like, including data input-output, what data do you provide to the system, what data do you get back from the system, layout, including look and feel. So, for example, if you're developing Microsoft applications, they have this UI standard document that specifies that, for example, you should always place a menu item for any button you have, so that every Microsoft application has the same look and feel. UI dialog structure, including when you navigate, when you perform a task, you need to go through a sequence of dialogues. And what's the structure of that, right? What's the sequence? When you click a button, what other dialog pops up? So UI prototyping determines how the UI will function from the user's viewpoint and gathers user feedback to evaluate and improve the UI. So prototyping refers to when you develop a mock-up, essentially, UI where it shows all the basic elements, but it doesn't do anything real underneath the UI. So it's important to know who your users will be. Not all users are the same. They may have different levels of expertise in the problem domain, different levels of knowledge of the system, different frequency of using the system, and different need to use the system. So they're not all like the software engineer. The user may be an 80-year-old grandma who has never used a computer before, or he could be a software engineer. For example, if you're developing application like Visual Studio, a IDE for software development, then your user is the software engineer. So your user can be very diverse. So what is the big deal? Because as software engineers, we need to understand the differences between different users, understand why the differences exist, and design to deal with the differences to exploit or minimize their effect. So we can try to make it easier for the user to use the system by designing the system for a specific user group. So tasks. So we gather information on current desired tasks, and that will help you in redesigning and designing tasks for the new system. So what is a task? A task is what the user wants to perform. So you have a top-down view where you can look at a task as a meaningful unit of work. For example, register for courses. Helps in understanding task goals and designing overall flow of events in the new system. So in this case, a task it often corresponds to a use case. Or bottom up, look at a task as a sequence of steps and actions. for example, specify semester and year as a step in the register for courses task, where you specify primary choices and specify alternative choices. They're all part of the register for courses task. Helps you understanding user's goals and identifying objects involved in the task. So this may look very familiar to you, right? So it is the use cases contain most of this information. That is, when you design the UI tasks, you should refer to the use case document and essentially pull out each use case as a UI task, user task, and flow of events as the bottom-up view of the task. Except you should phrase these in terms of the UI. That is, which button you click and what dialog pops up, etc. So try to identify breakdowns in current tasks as these are opportunities for improvement. What is a breakdown? It is a situation where the flow of the current task is awkward. Some goals cannot be accomplished because of some UI shortcomings. So that is, when the user tries to find the next button to click, that is a breakdown. A smooth UI flow should be guide the user from start to finish without any breakdown interruptions. So UI elements identify what data the user will manipulate. So when you're designing a UI, you need to decide what to put in a dialog. So that is the UI elements. Consider actors that interact with each use case and ask, what information does the actor need to supply to the system? What information does the system need to supply to the user? Which of the domain model classes are suitable as user interface elements for the use case? That is, the domain model class student. Should you put it on the UI? Well, if it's a student registration, part of the registration use case, then you should put it on the UI. Which are elements that the user work with? What actions can the actor invoke? And what decisions can the actor make? So these determine the buttons and perhaps a choice box on the UI. What guidance and information does the actor need before invoking each action in the use case? So you should provide the necessary information in terms of perhaps pop-up dialogues. So here we say actor is really equivalent to users, because there are two types of actors, remember. One is a human user, one is the external system. So we're designing the UI, then we're focusing on human users, not say the billing system as the actor. So register for courses. UI elements include to register the following information: semester, year, course code, offering ID, and priority as primary or alternative choices. So these should form the UI elements. So to find these UI elements, we consider the register for courses use case and determine what information passes between the user and the system when performing the use case. So you pull this information from the use case specification. And for each UI display or a dialog, we need to decide what UI elements are needed, how the UI elements will be represented, and where they will be placed. So they can be a text box, or a selection box with a predefined set of selections. For a text box, you can enter free text. To design the UI layout, you can use a sketch, that is PowerPoint, or sticky notes, or just pen and pencil, to draw a rough layout of the UI, or we can use prototype for the most important actors to get their feedback. So a prototype is something that's executable. You can actually run it. It's an exe file. And you can click buttons on it, even though it may not do anything. So we also need to verify that each UI layout provides a consistent look and feel and way of working. So that is, you should, when you're working with a particular application, you should try to do the same things the same way. Shouldn't change your style abruptly in the middle. So complies with standards like button size, toolbar placement, etc. So standards can be from a specific company like Microsoft, or it could be from internal guidelines of a company. So here's the register for courses UI. Here's one option. So you enter the semester. You enter the semester as a drop-down box, the year as a drop-down box, and the course code, course title, which is filled in automatically when you select the course code, course offering, and alternate yes or no. So if it's yes, then it's alternate. If it's no, then it's primary. So the way you use this dialog is you first select, say, Comp211 and fall 2008, and then click register, and then another dialog box pops up, the same but dialog box, and then you select Comp252, and then click register, and you do this for 4 times. If you want to register for 4 courses, plus 2 alternative courses, you do this for 6 times. So then the other option is to place these 4 primary course choices on the same dialog, and 2 alternative choices here. All the others are the same. And then when you fill in all 6 courses, you click Done. So obviously, this one is better than the previous one. So why? Because you need to keep track of less information in your head with this choice. Well, in the previous one, you need to think, okay, how many courses have I selected and registered? How many are left? You kind of lose information about what you have done before. But for this dialog design, you know all the information right there on the same dialog. So you don't have to remember anything. So the usability is obviously the option 2 is better. So as you can see, this design is done with PowerPoint. You didn't develop any prototype or read any code. So this is a typical way of initial rough design by user interface. Then a dialog description. So for each user task, we construct a mainline dialog description that describes what the user normally has to do to complete the user complete the task using the UI, ignoring any error conditions. So this is a step-by-step instruction description of how a user and the system interact via the user interface to accomplish a task. That is a scenario. So this sounds very familiar, right? This is just the flow of events of a use case. Except now the dialog description is in terms of the UI elements. So in the use case flow of events, you specify things, specify what you want to do without specifying how you want to do it. But in the UI specific dialog description, you specify exactly which button you click, and which choices you make, and which dialog pops up next. So it's essentially a line-by-line translation from the use case description into a UI dialog description. So dialog should be described from the perspective of the user, not the system. So the user does something, and user sees something in response. User does something again. So dialog descriptions are analyzed procedurally to verify that the steps involved are efficient and accomplish the desired task. So you can use sketches, mockups, prototyping to do a walkthrough of the steps involved and see if it flows smoothly or if there any breakdown in the flow. So the goal of dialog description is to be seamless. That is, when an object or function is needed for a task in progress, it's right there. You shouldn't make the user hunt for something all over the place. You should try to bring this thing to the user.
Excuse me.
Yeah.
What do you mean by mockups?
A mockup is essentially something you write, you develop that doesn't do anything. So it's an empty shell of user interface. So you can. It's similar to prototype, except the prototype may actually do something beneath by when you click a button. But a mockup is essentially a pure UI where you develop this thing, you can click on it, but nothing happens. Yeah. So here's the dialog description for register for courses. So you have this style. It's very similar to flow of events. One, the system displays the register for courses form with the current semester and year as the default. So you do this after you designed the UI elements. So now you know you have a form with the semester and year as selection boxes. And 2, if necessary, the user selects the semester and year. 3, for each primary course, user selects a primary course code, displays the course title. For each alternative course, it does something. And the user clicks the Done button. System displays the status of the course registration, succeeded or failed. So this description is obviously for the option 2. Dialog box design, where you have all these 6 choices on the single dialog. So, as you can see, this is very similar to flow of events in use case specification, except now you have the UI elements available, and you should phrase the statements in terms of the UI elements. Say the Done button, the form, and so select a course code from the selection box, etc. So much of this information can be found in the flow of events. So we need to put individual UI displays together into a dialog structure for the UI. So that is a sequencing a flow between individual displays, optional versus required displays, and dialog style in terms of menus, forms, commands, function keys, and shortcuts, input aspects, what the user can perform, what the user can input into the dialog, for output aspects, where what information the system presents to the user. So there are many alternatives from which to choose. So that is the dialog structure design. In the previous example, we don't have any structure because we have a single dialog. When you click done, you're done. You're done with the registration task. But for more complex user tasks, you often need to navigate through a sequence or a dozen or more dialog boxes. And then it becomes important to design this dialog structure so that the flow is smooth for the user's perspective. So software engineers need to be aware of what alternatives exist and learn something about user-friendly design of the dialog structures. So UI prototyping can help to get user feedback and evaluate alternative dialog structures. So general usability principles are consistency, that is similar actions in similar situations. You should use identical terminology in prompts, menus, and help, and similar syntax. So user shouldn't have to learn many different protocols. Accuracy and completeness, this information must be as accurate as complete when using the system as without it. So you shouldn't provide too much information to overwhelm the user. You should provide useful information, but not more. Speed, a task should not take longer to do with the help of the system than without it. That is, if a task takes longer to do with your system, then the user may prefer not to use your system. The reason to have the system is to help the user speed up his tasks. Shortcuts can help. For example, you all know the Control-C, Control-V shortcut in Windows, where you can quickly do something. Feedback, there should be informative feedback for every user action, but do not overdo feedback. That is, for some minor actions, you perhaps you don't have any feedback, but for some major actions, for example, when you delete a file, you should provide a feedback to ask the user, do you really want to delete it? It's an irreversible action, so you should think about it carefully. But for some minor actions like renaming a file, perhaps you don't need to provide feedback. Closure, that's when you organize actions so the user knows that a task has been completed. So for example, in the course registration system, you may provide a dialog box pop-up to tell the user that you have successfully registered for the courses. Error handling, to minimize a user's opportunity to make errors. So to reduce keystrokes. For example, in the registration dialog, we placed the course code as the selection box, and the course description, course title as a text box that's filled in automatically when you select some course code, right? If you ask the user to type in the course code or the course title manually, then it's very easy to make mistakes. A typing selection box avoids any typing errors. So action should be reversible. That is, you should gather all the inputs from the user and then send it out as a whole, right? Before you send out the information to the database, it should be reversible. You should have a back button where you can redo something, as opposed to the bad design where you send everything the user enters into the database immediately. So then it's not reversible. So users should always feel in control of the interaction, not the other way around. And load on the user's cognitive short-term memory should be minimized. So for the example before, for option 2, the load on the user's short-term memory is very small. But for option 1, you have a higher load because the user has to remember the history of the courses he has registered for. So I think we cannot complete the chapter today. So I'll see you next time. Remember to fill out the survey. It'll be very helpful to help me improve the teaching.